I built this modular assembly line system in Unity from scratch in under 2 hours using AI to speed up the process. And here's how I structured everything, so it's expandable and easy to finish. So the first thing I did was I imported the basic products, which I found myself. I wanted to use fruits and some basic ingredients that's usually used in baking. So what I did was I sent Gemini a list of the products I had, which at the time was these. And I said to him, make a complete list of the future products and recipes that I can use in my game, having 4 levels, and using a converter machine and a crafter machine. So this is what it came up with. I basically just got the list, level 2, processed goods, which just uses the converter machine. To see, we can make flour. And in my case, I wanted the converter to be quite simple, so the only thing that the converter does is convert a level 1 product into a level 2 product without any extra work. So a wheat turns into flour, apple turns into apple juice, and so on and so on. But in level 3, we see that we get the recipes. So for example, if we wanted to make apple pie, for example, we would need 1 apple, flour, and some butter, and then we would get an apple pie in return. And since this would require both the converter machine to be purchased and the crafter, and it would need 3 different items, this is going to have a much higher sell price. So the level 1 goods you can basically sell for nothing, level 2 you can sell for a little bit more, level 3 a little bit more, and when it comes to the level 4 products, you can sell those for quite a lot. So these products are basically the level 3 products just packaged. So apple pie is packaged apple pie, the applesauce is just the packaged applesauce. So we'll get back to this in a second. But for now I'm going to show you the grid system and how things actually move and work. So the first thing you see is that I have a lot of regions. And this is another example of how I used AI in my code to be more efficient with my time. I pasted the entire script into ChatGPT and asked it to generate regions for me to clean up the script a bit. So for example, if I have a problem with my input, I can simply go into here, into my handle input. And when I open this, I can safely know that this is everything about the input in this script. So if I have a problem with my input, it's probably going to be inside of here. So as you can see, I have this comment here which summarizes quite well what the script actually does. It says manages a 2D grid, object placement, and player input for a building system. And the script references the placeable object script here quite a lot, because this is the base class for all the placeable objects and machines in my program. So for example, my crafted machine, it's derived from machine, which is then derived from placeable objects. Or my spawner, which is directly derived from placeable objects. So as you see in the script, we mainly work on the direction and the rotation of the placeable object, and also have a virtual function here for the initialization. You can see convert your local direction, for example, this object's left to a world direction. So as you see here, this is everything in the script. It's not that big, but it handles a very important thing, which is the direction. And the direction in this game and the rotations are very important. As you see here in the summary, converts a local direction, for example this object's left, to a world direction, based on the object's current rotation. So as you see, we have these references to the direction. You see here, direction, 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 direction. And that's because in this entire codebase, I have this enum here, the direction enum, which has 94 references. You can see it's used all over the codebase. And having this public enum here makes it much easier to work with the directions in the program. So back into the grid system, I'm going to explain a little what this does and how you can recreate it. So first I have this public class, placeable object data, which is where I actually go in and add the placeable objects. So what I do if I wanted to add a new machine, I would simply go into here, I would give it a name, a hotkey, and a prefab, and the prefab does require a script. So every object you place, like conveyors or machines, they are defined here. And the system here, it's quite efficient for those who like to build fast, because this system lets you build, rotate, and delete with just one key. So you never break your flow. And the hotkey system is quite easy. As we talked about before, we just assign it a hotkey right there. And this function is where the placing actually happens. So the first thing we do inside the handle placing is we check if the clicked cell contains an object already. This is a dictionary, as you see here, with both the cell and the game object that is potentially inside, or if we actually have a placing object selected. If any of these are true, then we simply return. Then what we do is we convert the cell we clicked on into a world point, and that's its own function, which takes in a cell. And after we get the world position here, we instantiate the new object. We do current placing object.prefab, and we spawn it at the spawn position with no rotation, and we also assign it to the game object go. And if you wanted a sound effect, this is also where you'd place it. And you might have noticed here where I reference a ghost, which is just the ghost before I place. So you can always see a live preview of where things will be placed, which makes building satisfying and also fast. So we can go back to the products. I have this nice folder here, which contains all the product prefabs. So setting this up is quite simple, but it takes a lot of time. I used maybe an hour on this to set up all the products. So as you see, every product in this game is a simple scriptable object, and it holds an ID, a level, a sell price, prefab, and also a icon for the UI. Nothing here is hard-coded. I can change the sell price here, and the sell price will automatically adjust, and as well as the levels. If I change a level here, the behavior with the machines will also change. For example, if I set this apple to level 2, it won't appear in the spawner, like it did before. So I can also show you how easy setting up a new item is. So what I do is I just will duplicate these, and I'm going to rename them. I'm going to rename this to yeah, it doesn't really matter. Really doesn't really matter really. I'm going to delete these anyway. Right now I just have a bomb sprite, so it's going to be a bomb. So after I've set everything up, I add the scriptable object here and just assign these. We can add it to our database, into the projects, add a new one, simply add that. And you'll see it get added to the spawner nicely. And what the spawner does, and all the other machines as well, is that it goes into the game database, and the spawner specifically looks for all the items that's a level 1, and it lets you spawn that item, so it just gets the prefab as well and initializes that. So I don't want a bomb in my game, so I'm going to delete that. So as you saw before, every physical product in this world links to its own data. When it spawns, it knows what level it is, what it's worth, and how to move. So that's that. Now I can show you the actual meat of the assembly line game, which is the conveyor belts, of course. And as I said before, it's derived from the placeable object base class. which mainly just handles its direction and rotation. So what you can see is that when a trigger enters the conveyor belt, it pushes the collider. Simple as that. When it stays, it also does that all the way until it exits. And when the product exits the conveyor belt, it goes into the product and it says, hey, you have to set your move vector to 0, which in other words means it has to stop moving. Then inside the actual push function, we first check if the grid system is attached. This is because, and as I mentioned before, this is to ignore the ghost, since the ghost doesn't have the grid system script attached. And also if the product isn't a product, or the item isn't a product, then we also return. We'll only move products. So in my game specifically, I wanted to use transform. I wanted to use transform-based movement. I tried rigid body-based movement, but I didn't like that they collided with each other and also weren't centered. So I wanted to have the transform movement instead to have more control of where my products actually land up and how they moved. So what we do is the products, we move them to the middle of the conveyor belt, and we also set the move vector to the correct direction, and we times that by the belt speed, which we also set here. So I used ChatGPT to speed up the first drafts of the movement and alignment code, and instead of using Google or Googling or writing from scratch, I just told AI what I wanted, pasted and tweaked the scripts. And that saved me 30-40 minutes right there. In this game we also have the recipes, of course, and if you remember from before, the converter only converts, it doesn't combine. So you see the recipes for this is quite simple. We just have an input, an output, a input requirement, and a time, which is for all of these. So right now we are at this point, right here. And if you go to the crafter, you see apple pie, for example. Yeah, right there, it takes in 1 apple, 1 flour, and 1 butter. And it gives us the apple pie, which is also a product prefab, just like the level 1 products. And the level 3, which are the package product, we take the level 2 product, as well as the package. And since it's all driven by just data, and everything is in the inspector, nothing is hard-coded, I can add new product recipes, levels, or crafting chains in just seconds. It's just copy-pasting and changing some values. Notice that I'm never hunting through a huge script or chasing bugs from Tangled logic. Everything in this codebase is modular, plug and play, and very extendable. And this is why I finish projects. I synthesize, I use AI for speed, and I keep everything stupidly simple. If you want to finish your games faster, work smarter, and get real support, check out my private community for solo developers. I teach you these exact systems, give weekly one-on-one help, and join a group that actually gets things done. Link down below.